Okay, guys, let's get started. And this is college algebra. What I'm going to do is let's consider this expression right here. And in this expression right here, we have absolute value of negative 5 minus 0. Now, that's the same thing as the absolute value of 5 minus 0, which, by the way, is the absolute value of 5. But it's all equal to 5. Now, you may be like, well, why did you go such a long way around the barn? It's all equal to 5. And indeed, I could insert one more thing here. I could note that, well, we usually just say absolute value 5 equals absolute value neg 5, which is equal to 5. In blue here, well, let me get my, so like this. But now notice there's a certain richness though to having the 0 in here, even though sometimes it can be pointless, maybe even most of the time. But notice absolute value of neg 5 minus 0 and 5 minus 0, they tell you a distance. They tell you that for the first one, we are told that the distance between negative 5 and 0 is 5. And for the second one, we are told that the distance between positive 5 and 0 is 5. Same thing. Distance is always positive. Notice that these last two things, they kind of withheld that from us. They were more sneaky about telling us. So in other words, the distance from negative 5, let me get the pretty editor here. The distance from negative 5 to 0 is 5. And, let me give me some room. And the distance from positive 5 to 0 is also 5. And I'd rather have the number 5 instead of the British spelling. Okay, so I have that. But that's the English spelling way to write it. But more formally, so the distance between these, what's the mathematical way of saying it? Just these guys up here. So the distance from neg 5 to 0 being 5, in mathematics, the distance from 0 to neg 5, or which is the same thing as the distance from neg 5 to 0 being 5, that's just absolute value neg 5 minus 0. So for this first guy, we have absolute value neg 5 minus 0. Or you could also write absolute. Some of you may ask, well, Jason, could you not write 0 minus neg 5? And you could. It's the same thing. That becomes 0 plus 5 in there, by the way. But I like to leave it like this because I'm wanting to keep the distance idea intact here. But anyway, that distance is 5. Okay? And for this next guy, absolute value 5 minus 0, which is, that's positive 5 in there anyway, but that distance is 5. This is a distance from 5 to 0, from 0 to 5. Let's say from the right guy to the left guy. Or you could say from 5 to 0, 0 minus 5. Now, you're thinking, well, what's inside here is negative. Doesn't matter. Absolute value gets rid of negative anyway. So that's just going to equal 5. Guys, absolute value, if you're negative, you're going to become positive. Now, if you're positive, you just stay positive. You stay that way. It's the distance from a number to 0 if all that's in there is that number. So in general, the absolute value of x is the distance from x to 0 on the one-dimensional number line. just the number line in 1D. The good old, kind of rather unexciting number line. So absolute x minus 0 is, indeed, or let me put furthermore, it is also the distance, well, having writer's block here, it is also the distance from negative x to 0. So, because after all, absolute x, well, equals absolute negative x. And I wish I'd make my minus sign a little bit bigger in here, but I trust that you guys can see the minus sign that's in the absolute value in blue right here. Well, I tried to make it blue anyway. So, absolute value of 5 equals absolute value of negative 5. The absolute value of negative 6 equals absolute value of negative 6, which is just positive 6, but they both have absolute value to 6. Now, the absolute value of 0, we define that to be 0. So, the absolute value of 0 is 0, which is neither negative nor positive. The absolute value of anybody else is positive. Like the absolute value of 0 is 0. So the absolute value of 0 equals 0. Otherwise, the absolute value of x is positive if x is not 0. Okay, 0 is neither positive nor negative. Okay, now the absolute value of x minus 0 is the same thing as absolute value of neg x minus 0, which is the same thing as absolute value of neg x, which is the same thing as absolute value of x in general. And this is the distance from x to 0. And it is also the distance from, what's the distance from x to 0 and from neg x to 0. Okay. Now 0 is not very exciting. What if we want to do distance from, say, 2 points that may not be 0 in general? Okay. And let me increase my fontage here. What if I do absolute a minus b? It is the distance from a to b. Oh, that's pretty. That's the absolute value of a minus b. And I'll show you how to handle plus cases too. So let's go give it a look. So absolute value of 5 minus 3. Well, let me get the pretty editor so my minus sign will be big. Absolute value of 5 minus 3. Well, absolute value 5 minus 3 is equal to 2. Well, we know it's equal to, it's absolute 2, but absolute 2 is just 2. Because absolute value it takes a minus sign off if you have one. And if you don't have one, you don't worry about it. So the absolute value of 2 is just 2. Now, so the distance between 3 and 5 is 2. Surprise, surprise. Now, it'd be nice to do one more that's a little more interesting. What about the absolute value of absolute value of maybe 5 plus 3 equals 8? Now, you'd be like, well, what do you do with this one? Absolute value of 5 plus 3 equals, well, that's obviously absolute 8, and that's obviously equal to 8. But we need to show more steps. This one is kind of muddy as far as distance. It's easy arithmetically. It's easy. But what about in terms of distance? Well, what about it? We can do something about that. We want to turn that plus sign into a minus. We don't usually like to go that way, but this time with distance, we kind of have to. We turn it into 5 minus neg 3. You're not used to having to do that, but you kind of have to. Well, you could also do, well, you have another choice. You could kind of use, it's just the other twin. You could use the other twin, which is 3 minus neg 5, and it skipped a line on me there. It is what it is. So you could either do 5 minus neg 3 or 3 minus neg 5. So what about it? The distance from, well, from 5 to neg 3 is 8. And, well, that's one point of view, and it's right. And the distance from 3 and neg 5 is 8. Both points of view, one's just as good as the other. They're both valid. That's what absolute value does for you. And like, let me just copy this framework so I'll have it. Now, if you have the same number plus the same number, like you would do 7, and you'd have like 7 minus neg 7. Now, there's really not a second. There's no two ways to view that guy. So that would be 14. Oops. And now there's just one way to view that guy. The distance from negative 7, let me use the pretty editor so my minus sign will be more visible. The distance from negative 7 to positive 7 is 14. Okay. Now let me do what I call the pedestrian case, the ho-hum case, the boring case. Now, what if I did the distance from what if I did 9 minus 9? Well, that's no fun. That's just, we've already got our precious minus sign. That's 0. There's not much to say here. That's just 0. The distance from 9 to itself, the distance from 9 to 9 is 0. From the point to, if you don't move, you're not going anywhere. Okay, so that's sort of the ho-hum case, right? That's not exciting at all, right? I guess I could save this file, but I might save it later. But anyway. I'll call it A2. How about that? Sounds good. Now, so this is what distance does for you. And all these little different cases you can have. And you can use pesky fractions. You can do things that are just downright pesky, like a half or 3/5 and 2/7. If you have like a 3/5, well, let me go down here. Now it made it real nasty. I've got to go down the page. If you have like 3/5 and 2/7, fractions are icky anyway, right? So it's 3/5 and then minus a neg. You got to have minus form with absolute value, right? You need this minus in the middle. If you don't already have it, you need to make one. So minus, then a minus. If you minus a negative, guys, it's good table manners. It's sort of good table manners to have a parens around the other guy. But anyway, I don't know how that got there. But now, if you have if you have that, now that's going to be 3/5. Now, so we want the distance between these. Now, to get that distance, I need to go back to my prettier form, right? We want to use the pretty form to actually do the math, okay? News articles. Sorry. Now use your calculator. 3 times 7 is 21. Well, you could do common denominator, LCD. Ew, okay. 21 plus 3 times 7 is 21 across the diagonal. 5 times 2 is 10. 21 plus 10 is what? 31. I multiplied across the diagonals. Now my common denominator, I'm not saying it may or may not be the least common, is 35. It actually is the least common, so we don't have to reduce. Good, okay. Well, let me check if I have to reduce. No, I don't have to reduce. I always need to check if I have to reduce. Always check, always. So, but I don't have to reduce. It's 31 35ths. That's always icky. So, but the absolute value of 31 35ths is 31 over 35. Use your calculator if you don't want to do that icky arithmetic there. So it's 31 over 35. There's other ways to do that. That's not the only way. How about I move that into the next board? We're going down there anyway. So, but you remember there's the evil twin, as I call it. I can do absolute, and what is it? 2/7 minus a negative 3/5. And again, it's good table manners to have this layer of parentheses like that. So, and oops, I made a boo-boo. I didn't mean to have a friends on that last roundabout. I meant to have a closing absolute value bar. So I didn't make a number boo-boo. I made a parenthesis boo-boo. So let me fix that now. I don't want you guys to think I'm half crazy here, or I don't want you guys to think that I don't know what I'm doing. Sorry. Let me not say that. Let me just say that. Okay. Oh, how'd that question get there? So got that. And well, so yeah, this is kind of the evil twin version. And yeah. Now, usually, unless the numbers are identical, you'll have an evil twin version. So they're 31 over 35 apart. Absolute value, unless it's identical, the absolute value will be positive. Okay, so what about this? Did I do it again? I typed parentheses again. I want you to listen. I want to get. I went back, Jack, and did it again, didn't I? Okay. Well, 3/5 minus. Okay. 3/5 minus a negative 2/7. I keep the numbers are right. It's pretty much right, and it's getting rid of my absolute value. It's not well. It's getting rid of my absolute value bar, and I don't like it, guys. I may have to use bad table manners because it's not being friendly. So it's 3/5 minus, and it's a negative 2/7, and it's been mean as a snake. I think what it is I'll have to keep these little without fonting them out. There we go. Okay, absolute value bar here, absolute value bar here. So what about it? The distance between, and let me get my pretty editor equation. So the distance between 3/5 and negative 2/7 is 31 over 35. Okay. And that shouldn't be capitalized, but I don't know if I feel like wrestling with it. And the distance between for the other case, really one's just as valid as the other. I really shouldn't say evil twin. 2/7 and neg 3/5 is the same. 31 35 is also 31 35. Okay. That's what we were saying up here. In other words, like this guy equals this, and this guy equals this. Okay. So I wanted to do a pesky fraction example, and I've got a dangler. Yep, let me get rid of that dangler. So I just scooted this equal sign right here on over. I had a little dangler that had no business being there. Okay. Well, if you have any questions, just shoot me an email. Now, well, what else do I want to cover? It kind of feels good not being on a time frame, but I know I don't want to waste time though. Let me go to, I wanted to go to view, view assignment. Let me go to home. Come on now, let me view it. I'm talking to an inanimate object. Okay, now we've said a big spiel about absolute value. Now here's the deal. I'm not going to spend a lot of time on set builder in this class. I'm not going. If I put anything on the test, it'll be open interval and closed interval and the mixture of them. Set builder, I just don't care for. I might do like Venn diagram or something. Now, open interval, guys. I got all these wrong because I just submitted it. I wanted the answers just to have a key in front of me here. Now, here's the dig. The set of numbers between but not include in between but not including 5 and 8 can be written as what in set builder? Well, I will do this for set builder just for completion. If I want to stay strictly in between, but I don't want to hit the endpoints, any x strictly in between 5 and 8 will be 5. It'll be the collection of all x. This vertical bar means such that 5 is less than x, but x is less than 8. Now here's the thing I want. Interval notation, x is an element of 5, 8 with parentheses. The parentheses mean that I don't include the endpoint. And in particular, parentheses plural means that I don't include either endpoint. So the parenthesis on the 5 means I don't include the 5. The parenthesis on the 8 means I don't include the 8. Now, you're like, well, Jason, what if you do want to include the endpoints? Then you would put the brackets, right? And you're like, well, Jason, what if you don't want to include the 5, but you do want to include the 8? Then you would do the top guy. Now, if you wanted to do just the opposite of that, you would do the second guy. But anyway, it's not, that's pretty basic, I think. So now, number 2, explain the difference between the following 2 sets of numbers. Now, with A, we include the endpoints. The left endpoint is -1. We call that the left endpoint. And the right endpoint is +2, in this case. Okay, we include them with A. With B, we don't include them. A is called closed, and B is called open. Okay, A is called closed, and B is called open. You may want to write that down. I don't feel like going back to Word. A is called closed, B is called open. With open you exclude. Okay. Number 3, I went into that with great detail, so we can move on down the highway with 3 and 4. We went into great detail. Distance and absolute value, positivity, except for 0. Now number 5, state whether the inequality is true or false. -7 is less than -11. That's actually bad, because -7, guys, on the number line, the further left you go, the more less than you are in nature. So -7 is greater. And we get the idea on these. Now number 7 is a good one. Now 9 is less than or equal to 9. Why? It's true. Why? Because of the equal to part. If it weren't for that equal to, this would be false. Now, if you had 9 strictly less than 9, without the equal to being there, this would be false. 9 less than 9 is false, but 9 less than or equal to 9 is true. Just keep in mind the borderlines for the inequalities. Like 9 less than or equal to 9 is true, but 9 strictly less than 9 is false. Like that. And let's see if I can skip a line. Yeah, like that. That's better. Well, it's just easier to read, that's all. Okay. Now, those are the borderline situations. Now, if x is greater than -4, what does that mean? That means that you shade everything to the right of -4, but not including -4 himself, because you don't have greater than or equal to, you just have greater than, so you don't include -4 itself, but so what you do is you put an open circle on -4. Well, if it'll be nice to me. And then you shade everything to the right of that. And did it get my open circle? Let me see. Let me see if it did it get it right. But anyway, everything to the right of -4. And I think I tried to get it. It's hard to pinpoint this thing, isn't it? Uh-oh. I think I messed it up. Let me get an eraser there. Well, I didn't want to do that much. Let's see. Let me put that. Perfect. Now I can get my little draw thingy. You go to draw, then you do your business. Yep, looks good. And you would hit enter, but there it is. Oh, okay. It did it down here in green. I'm silly. I'm not paying attention. But yep. So, and notice, guys, you have the empty hole. Why did I use the empty hole? Because it's strictly greater than. Now, why did I go to the right and not to the left? Again, well, it's greater than. If it had been less than, we'd have went to the left. Now you're like, well, Jason, what would you have done if that would have been greater than or equal to? You would have used a dot like this. Well, if it had been greater than or equal to, I would have used a dot, and then I would have went to the right. Well, if I can move it around the right way. I'd have used a dot, and then I would have got my shading, and then I'd have went to the right. Now, guys, that's only good. That's x greater than or equal to, right? But they don't have the equal to here, so you can't really do that. So I need to get rid of that. I can't do that this time because we don't have the equal to part. So yeah, I need to erase that. But anyway, it's the empty circle here, okay? Anyhow, so x less than -8. Now less than, you go to the left. So just think of it like this. As long as you're in standard position with x on the left and the number on the right, if the mouth is opened up at x, notice how the mouth is opened up at x like Pac-Man, the classic 1980 Pac-Man. The mouth of the inequality is opened up at x. So you're greater than. So greater than is rightward, always. But now down here, the mouth is pointing away from x, so you're less than. So you're going to go leftward. And because you're just less than, you're not less than or equal to, you're going to put an empty hole at the critical number, -8. So you do everything less than -8. Like you would have -9. You would have even -8.0001 is okay, barely, right? But still okay. -1 trillion would be way, way, way out to the left. So on, so on. Here we go. Here's less than or equal to. Now x less than or equal to positive none. Now you go to positive none, and because we have equal to, you put a solid dot, right? And now less than means you still go to the left because it's less than after all. So you go to the left. Now and you do that because it's less than. All the equal to does for you is that makes you a dot. That's all equal to does. It's the less than that makes you go to the left. Okay, be careful about that. Okay. And then now find the inequality. Now here they give you the graph and they want you to get the inequality itself from the graph. They want you to think backwards. Well, it seems to me like 7 is my critical. So 7 is the guy that goes on the right. We're going to the left, and we have the filled in black dot. So we're less than or equal to. Left filled in. Left is the less than. It's going to, just because going left is already enough for a less than, filled in at the dot means equal to. And your x goes here at the left. We could have done that a long time ago. Okay. Again, put the x on the left. Now 7 here. And it's just like the other one except we got a white dot here. So we don't put the equal to. That's the only difference. You see, these guys are cousins, except we got the white dot here, right? So unlike its cousin, less than or equal to, less than has the white dot. You can't put on the second one, on the second cousin, you can't put your foot on 7. Whereas on the first, this cousin up top, you could put your foot on the 7. Okay. Now for number 13, you go to neg 3 halves. By the way, guys, neg 3 halves is the same in decimal mode as neg 1.5. Now greater than means you go to the right. The mouth is opened up toward the x, okay? Now there's no equal to that I see, so it's going to be a white dot, and you're going to go to the right. And I think and now here's greater than or equal to, so we have the black dot. And we go all the way to neg 6, but we're eventually going to go, the direction is going to be rightward at the end of the day. We'll end up at like positive million if you go far enough. Positive million will be part of the package, and beyond, well beyond. Okay, now you would any number beyond neg 6 to the right is there, like a positive million will be on this arrow. Now, guys, write each statement in terms of inequalities. Now, x is positive. Anytime I tell you that something's positive, it means it's greater than 0. So just x greater than 0. And again, greater than is when the mouth opens up toward x for the inequality symbol. Now, t, if they give you the symbol t, you have to use t, as in Teddy. T less than 4, you have to use less than 4. Now this time the mouth is away because it's less than. Okay. Now greater than or equal to, again, you do the greater than sign with the little equal to below it. And then you just put the number neg 8 over here. Okay. And I think now D is interested. Now x is less than 1/4. So it's to the left of 1/4. So we do x mouth away 1/4, but x is greater than neg 3. Now guys, here's where it gets a little, you have to stay with less thans. You can't use the greater than symbol because we want to, it's true that we could technically write x greater than neg 3, but we need to write its equivalent. X, it's true. X is greater than neg 3. I agree. It's true. It's absolutely true. But we need to say the equivalent thing. Neg 3 is less than x, right? After all, if x is greater than neg 3, and it is, then it's certainly true by logic that neg 3 is less than x, right? If McDonald's is cheaper than Longhorns, then Longhorns is more expensive than McDonald's, right? So X is Longhorns. You could think of -3. I'm not being derogatory toward McDonald's. No offense for my McDonald's fans. -3 is McDonald's. I'm just using this as an analogy. I love some things from McDonald's. No offense. It's just expensive. I'm just using expense, okay? No other reason. So no throw off at all. So expensive, less expensive. So if X is greater than -3, then -3 is less than X. So -3 is less than X. So McDonald's, now X is Longhorns, now 1/4. X is less than 1/4. So if X is Longhorns, 1/4 would be like eating at, imagine 1/4 is like an upscale restaurant in New York City. That would be like $300 a meal. It would make Longhorns look cheap. Imagine 1/4 is like Mickey Mantle's restaurant in New York City, in Manhattan or something. But imagine 1/4 is like $40 for a hamburger, $300 for a steak. So 1/4 is like crazy high. So -3 is less than X, and X is less than 1/4. Everybody is less than 1/4 in this pile here. Okay. So -3 surrenders to X, and X surrenders to 1/4. Everybody in this is going to surrender to 1/4. Okay. So the reason why you have to write it this way is because you want all less than. You got to wedge X in the middle. You want the X here in blue to be wedged in the middle. If you wrote X greater than -3, which would be technically correct, you couldn't do any middle wedging. And we want to do the wedge in the middle. Okay, so greater than, and what they're saying here is X is less than 1/4, and X is. There's a the X goes here again, and X is greater than -3. So you want to turn this second guy into -3 is less than X. So -3 is less than X. Let's go to Word. So -3 is less than X, and X is less than 1/4. So -3 less than X less than 1/4. I'm using the basic editor there. I'm not using the pretty one. Okay. You got to turn it into that. And let me use a comma just for prettiness. So we have this guy. So we have -3 is less than X, and X is less than 1/4. And then it all falls into place. You need to get used to this, guys, or it'll kind of be hazy to you. Okay, now let's read part E. The distance from P to 10 is at most 1. Now, at most means no more. So the distance from P to 10, remember, guys, that's absolute P minus 10. We talked about that earlier, right? If that's rusty, go back. So absolute P minus 10 is at most 1. Now, it can be 1. If one of you guys has, like, let's say one of you guys is standing at point P and the other one of you guys one of you all is standing at point 10, that's fine, but I don't want you all to get further than 1 unit away from point 10. I want P to be either at 9 or 11 if it's one-dimensional. Imagine now if it's two-dimensional, you could be on a circle, but you have to circle radius 1 around 10. But anyway, the absolute value of P minus 10 has to be less than or equal to 1. You can get one, if I'm at 10, you can get 1 unit away from me. Like you could, if it's in 2D, which pretty much we're restrained to a 2D world here. We can't, it's hard for us to go up or fall down without getting hurt. So, like, imagine we're on a flat board or just a flat field. like, and we're in yards. I'm at a 10-yard line. Like, I'll let you go as far as the 9 or 11-yard line, but I don't want you to go any further. You can go that far, less than or equal to, but I don't want you to go any further. So the absolute p minus 10, I'm at 10, you're at p. It's a difference because it's our distance. You know, but now you may be closer than that, just don't get further than that, right? It's okay for you to be closer, just don't be further. And it's what we talked about earlier. Now, number 16, now write each statement in terms of inequalities. Now, if y is negative, strictly negative, it's less than 0. Now, if z is greater than 6, well, z greater than 6. The mouth opens up towards z. Now, negative, guys, remember what that means. That means you're less than 0, and the mouth is away from y. Okay. Now, b is at most 3. b is no more than 3. So the b is either below 3 or at 3, but b cannot go further positive than that. So b could be 2.999, b could be 3, but that's the best you can do. And so b is less than or equal to 3. B could be 2, b could be negative 5, but you can't go to, it would not be allowed to go to 3.01. That would be bad. 2.99999 is okay, but you can't go to 3 himself is okay, but no further to the right. Now w is positive and less than or equal, so w is positive. So that means, yeah, so it's the second guy here where this green key is. So 0, now we want a wedge. So if w is positive, yeah, I know it's w greater than 0, but remember, wedge. 0 less than w. We want that, right? W greater than 0 to say the same thing, 0 less than w. Okay, so we want w to be above 0, but at the same time, less than or equal to 14. So less than or equal to 14. So we're wedging w such that w is strictly above 0. W is strictly positive. W cannot be 0. It's strictly positive, and w could be 14, but w cannot go any further than 14. Like w could not equal 14 and a half or something. That would be forbidden. W can't go any at all beyond 14. You can't even do 14.0001. That's forbidden as well. 14 himself is fine, or 14 itself is fine, but you can't go any further. And why is 14 itself fine? Because of the equal sign. The same reason this guy was fine. It's the equal signs, right? Now let's look at the third one. Now w can be 14, but no, so wait, that's not right. The second one's right. I was thinking we were the next problem. Sorry. So w is, yeah, they always put the green key. I was thinking that they were wanting me to analyze that for the next problem. I don't know why. So yeah, w is positive and less than or equal to 14. So w is strictly above 0, and w can be at or below 14. Okay. Yeah. I was thinking this was problem E. Don't ask why. Don't even ask why. Okay. Now, y is at least 2 units away from 7. Oh boy. Now, I'm at 7. Now, this time, imagine, like before, when I wanted you to stay close, it was like I was snapping the football to you, right? If I was the quarterback, you would be the person I was snapping the ball to. I wanted you to stay close. This time, you're going to be the person I'm going to throw the ball to. So I kind of want you to stay far away. I want you to keep some distance from me. I want you to go further out there. I want you to stay a little bit away from me. You don't need to be too close to me. You won't be able to go get outfield enough. So y, on part E here, y is at least 2 units away from 7. I'm at 7. You're y. You need to get out there a little bit. So y distance is absolute value difference, as always. Absolute y minus 7. And I want you to be, you can be 2 away from me. That'll be okay. You don't, imagine I'm going to do like a short mid pass, but you don't need to be just right there beside me though. You need to be 2 units away from me, and if those units, you need to be at least, let's say, 2 yards from me or whatever. So absolute value, if the units were yards, so absolute value y minus 7 greater than or equal to 2. The key word here is the symbol, the greater than or equal to, because I want you to stay away from me a little bit. I want you to stay at least 2 yards away from me. You can be 2 yards away from me, but no closer. No closer, because I may throw the ball to you. And it's going to be funny if you're too close to me. I don't want to do an underhand pass. I want to throw it to you hard, with some oomph, right? I want to throw the football to you, and I want you to run downfield a little bit or something. Imagine it's going to be, well, when I say a short pass, it's not going to be real short. It's not going to be an underhanded. I want to throw it, with a little bit of gusto. I want you to have, be a little bit far away. Now, so why am I? It's either it's either going to be the first or second choice, but the first choice is bad. I don't want you to be close. This time it's at the key word is at least. I want you to get away from me a little bit. Okay. Now let's go down and look at number 17. Okay, on number 17, find the indicated set if we have the following. Now, this is a different topic. This is a change of the guard. We're talking about union and intersection. Sometimes we call these symbols cup for union and cap with an A, C-A-P, for intersection. Cap, C-A-P, for intersection here on part B. And cup, C-U-P. And it looks like a cup you could pour water in for part A, the union right here. Now, here's the deal. Union means everybody climb aboard. As long as you are in one of the sets, you qualify, and I will list you one time and only one time if you popped up in either of the originals. So A union B, if you are either in A or in B, I'm going to list you in this A union B, but I'm only going to list you once. If you were in A or B, doesn't matter. If you were in both of them, doesn't matter. It doesn't matter. But I will list you, just so you weren't totally absent. I will list you one time. One time. No more, and I'm not going to list you twice. Or I'm not going to list you more than once. I will list you once. You will get listed one time. So let's look at it. A union B. One is in A, so he's listed. That's it. That's all I need to know. You will not be double listed though. Now 2 is in A, that's all I need to know. 3, 1, 2, 3, 3 is there, all I need to know. 4 is there, all I need to know. 5, 6, 7, there they are, all I need to know. Now I don't see 8, so I go to B and I snoop for him. Okay, there he is. He's fine. So he's there. So there it is. 1, 2, 3, 4, 5, 6, 7, 8. Now what about 9? What about 9 and 10? No, I don't see 9 there, and I don't see 9 there. 9 is not in A, he's not in B, he don't qualify. It doesn't qualify. 9 didn't make it, and 10, in a similar vein, 10 doesn't make it either, right? 10 wasn't in either A nor B, or 10, so 10 didn't qualify. 10 was in neither A nor B. Now, that's how you do the union. Now, let's look at the intersection. Now, A intersect B. Now, this is different. You have to belong to both, or you don't qualify. You need to be in both. I'm only going to list you once if you belong to both. If you don't belong to both, you're out of luck. So 2 is in here, but that's not good enough for part B. Is 2 in here? Yes. Now 1 was not. Now let's look at B, because B is skinnier. Now 1 is out because 1's not in B. 2 made it. 4 is going to make it. 6 is going to make it. So there's 2, 4, 6. Now 8 is here in B, but 8's not in A. I don't see it. So no. 8's out. 8 didn't make it. So it's just 2, 4, 6. That's how you do union and intersection. When it's the upside down cap, you have to belong to both. Like an intersection of the highway. Think about intersection, guys. If you've ever had a fender bender, it's where the cars intersected. They both were at the place. Well, when they shouldn't have been, but anyway. Union, union. I guess good. Like a wedding is good. But anyway, or whatever, or just or a more general union, a union of banks or whatever. Intersection could be less negative. It could be the intersection of a highway, right? You had to be careful. Right? But anyway, now union and intersection. Now intersection. Now B intersect C. These are a little different sets. Well, A is the same, but B and C are a little different. Now B intersect C. Now the only thing B and C have in common is 7. So that will be the answer for B intersect C. Because 7 is the only thing that belongs to both. Now B union C, now all you need to do is just belong to one or the other. We're not even going to consider set A this time. So 1, cool. 3, cool. 5, cool. 7 is there. And hey, we can go ahead and throw in 8, 9, and 10 in the pot too. Because that's just union. Union is nice, right? So that's really cool. That's neat. Now, intersection. Guys, sometimes intersections are empty. Sometimes sets have nothing in common and you don't have an intersection. It's empty. Like, that happens. Union will never be empty unless all the sets themselves are empty. Now, intersection, A intersect B intersect C, you got to belong to all 3. That's tough. Now, 1's out. 2, well, it doesn't belong to C, does it? Oh boy. 3 is out. Yeah, it doesn't belong to B. 4, it doesn't belong to C. 6 doesn't belong to C. 5, yeah, it doesn't belong to B. You got to belong to all 3, so I can whittle out in a hurry. 7 doesn't belong to B. Empty set. It's the set that contains nothingness. Guys, the empty set is the set that contains nothing at all. It's called the set of emptiness. It's the set, it's the swervy swirl brackets. They have these brackets here, so they already create the set for you. But it's the set that contains nothingness. Literally, it's vapid. It's the vapid set. Really, they put the word EMPTY in here, but that's just a nomer. The real empty set is the set. Literally, it's just you just write brackets and that's it. It's the empty set. It's the set of, well, nothingness. It doesn't have anything in it. Now let's go to part A. A union B union C. Now this is going to be everything listed one time. 1 through 10. It's hard not to belong, right? It's a single listing of everything that belonged to at least one set. Okay. Now number 20. Find the indicated set if. Now here's where it gets a little bit harder if you go into like intervals and all that good stuff, and a 3-way. Now these are unorthodox, but very helpful in getting interval notation. Hey guys, what I did there was on that part there of the video, the ABC part is x greater than or equal to -2. That's the same thing as -2 less than or equal to x. But notice there's no restraint to the right. So you can just as well say x is less than infinity. And that's important because I want to wedge x in between somebody. And if there is no somebody, you just put infinity. And since it's our unboundedness is to the right, Well, positive infinity stands for forever to the right. Or it's in the positive sense. We're unbounded in the positive sense, so we use positive infinity here. Now for B, we're unbounded in the negative sense, so we use negative infinity here. Now we're quite bounded. For B, we're bounded by positive 2 to the right, so we can't we can't do any infinities there. We don't want to. Likewise for A, we did not want to do negative infinity because negative 2 is our bound. And for C, we can't do any infinity because we're bounded by neg 1 and 3. So I just wanted to clarify that. And I'll insert this clip inside. Now, so what about it? So now B union C hey, B can be, we don't have, hey, we can take these, we hate set builder. I never did like set builder. Let's just write these in interval notation. Let's be done with it. For goodness sakes. Let's write these in interval notation. So that's neg 2. A is in neg 2 comma infinity. B, or A equals that. B is the interval. Now, guys, you never put brackets on infinity, or neg infinity for that matter. B is neg infinity to 2 parentheses, because that was the way it was given. And then C is equal to, now notice, but I put parentheses on that 2. X was strictly less than 2, so I put a parenthesis on that 2 right here, right? Now C, now we got neg 1, where neg 1 is strictly below X, but X is strictly, but 3 is strictly above X, right? But we have 3 is strictly above X, so we're going to have C is equal to, well, it took me out of the editor, hot dog. Negative 1 comma 3 bracket. So, with that being said, now B, let's do it. Oh, thank goodness, thank goodness, thank goodness. We made it to interval notation. So, insert. Okay, B union C equals, now less strict, and let me just put, that's going to be less strict to less strict. It's going to be less, now, what's the less strict restraint? Which is it's easier to hit the bullseye at neg infinity than it is neg 1, right? And now, so it's going to be, so which one is further to the left? Neg infinity or neg 1? Neg infinity, right? So that's the one we choose. And of course, neg infinity never has a bracket. So we're going to have to use a parenthesis. So neg infinity. And now we look at the right guy. 2 or 3. Which one is further to the right? 3. Now, does 3 have a bracket or a parenthesis? Actually, it has a bracket. If you'll look at C right here, we have a bracket right here. So we put a bracket. Well, not right there, but right here. Okay, guys. One thing I should have pointed out, what I'm saying is true. It turns out just fine and dandy, but it only works because of a thing called the litmus paper test. And that test is as follows. It works because B and C overlap. And they overlap because negative 1, the extreme left point of C, is an element of B as well. Indeed, negative 1 is in between neg infinity and positive 2. Or you could go the other way. 2, the extreme right point of B, is an element of C. Indeed, 2 is in between neg 1 and 3. If they don't overlap, everything goes out the window. I can't do what I just did. But since they overlap, I can do what I just did. I should have pointed that out first thing. I call that the overlapping litmus paper test. I so should have done that first, and I'm sorry that I didn't. On subsequent problems, I'll be sure to do that. Now, because they overlap, I can do generous lefty to the corresponding generous right-hander. The more negative lefty is neg infinity. The more positive righty is positive 3. So I run as far to the widest interval. B union C is the widest interval I can achieve, which is neg infinity to 3. Now, and that's good, and I just adopt the Princier bracket that is there. Neg infinity, as always, has a parenthesis. Now, 3 this time around had a bracket, so I keep those. But anyway, now again, this only worked because it passed that litmus paper test. Had it failed, I couldn't have done it. Indeed, had it failed, this would have been like a disjointed. This would have been a graph of disjointed intervals. And we couldn't have done anything except just graph them. We couldn't have cleaned this up at all. But it passed this time around, but I should have been more careful. Thank you, guys. And I'll do more examples like this later on down the video. That's what we're doing after all. So the moral of the story, the main idea, we go from the leftmost to rightmost. In this case, it was negative infinity, which always has a parenthesis. Negative infinity parenthesis to 3 bracket. And the infinities always will have, and let me just put a note that the infinities always have parentheses. And that was kind of an aside, so I'll just put that, I'll just isolate that off. Now, so for union gives us leftmost to rightmost. And I think I hyphenate those. My English was kind of off there. So union gives us the leftmost to rightmost relative to B and C. So union gives us leftmost to rightmost relative to B and C. So B sent us to neg infinity to the leftmost because neg infinity is way further to the left. It's infinitely further. And then between 2 and 3, 3 is a little bit further. And now, okay, now the deciding guy was my 3, and my deciding guy 3 had the bracket on him. Oops. It scrolled down on me there, or up on me. So you look at your deciding guy. Your deciding guy for the right hand was 3, and it had a bracket. Your deciding guy on the lefty was neg infinity, and neg infinity always will have a parenthesis. So it's parenthesis on the left and bracket on the right. Okay, so we have our union, and that's nice. Now, what about intersection? Now, what if I wanted to do intersection? What about B / cap C, the intersection? Okay, now, it's the more suffocated, or it's the stringent, the stringent left to the stringent right. It's very different. So the more stringent, now -1 is much more strict than neg infinity, right? So you would go from, and -1 has a parenthesis on it. So you would go from -1, okay. Now let's look at the right-handers. 2 and 3, this time 2 is more stringent. And 2 is now my decider, and he has a parenthesis on it. So it's -1 to 2. So B union C, intersect. So B intersect C, which is with the cap, B intersection C is equal to neg 1 comma 2. Wow, okay, much more strict. And notice this interval is much skinnier and reclusive or exclusive than this generous interval B union C, right? This is generous, this is stingy, right? The cap is stingy, the cup is a rather generous interval, right? Or is a rather generous interval. Okay, union and intersection. So recapping, we got our A, B, and C. Now this right here was what they gave me, but this is messy. Those greater than symbols, this is correct, but it doesn't tell me much. You need to get it like this. You change your greater thans to less thans, and you bring on the infinities if you need them. And we did need them here. Now, and if you have your less thans but you don't have your infinities, you put in your infinities, like part B. Now, if it's fine, you leave it alone, like part C. And then you convert to interval notation, neg 2 less than or equal to x less than infinity. That just, you can tell immediately x is between neg 2 and infinity, so you write neg 2 to infinity. X is between neg infinity and 2, so you write neg infinity and 2 for B. And for part C, x is between neg 1 and 3, with the neg 1 not included, but with the 3 included, so you write neg 1 parenthesis, comma 3 bracket. We're doing everybody in between neg 1 and 3, including the 3, but not including the neg 1. And for B, we're doing everybody to the left of 2, period, not including the 2. And for A, we're doing everybody to the right of neg 2, including the neg 2 himself, or itself. Because we do include the neg 2 because we've got the bracket on it. Okay. So that's okay. So that's all that. Now, union and intersection, yeah, it's a little more delicate when you have this. Notice how much nicer interval notation is. It tells you more. And guys, I was trying to do this with the number line, but in a way I like it this way. It forced me to be analytic and rigorous, not having the geometry in front of me, not having the ink pen and the blackboard and the expo in front of me. It forced me to use rigor, forced me to be sort of rigorous. But that's cool. Okay, now let me go back. So number 20, that was a change of the guard, right? To say the least. Okay, now 21, you do it the same way. Guys, I would lose my sanity if I had to do that again. But you know what to do now, right? Now, number 22, guys, now this is the half open, half closed interval from 8 to 10. You put an empty hole at 8 because it's got a parenthesis on it. You put a complete black dot at 10 because it's got a bracket on it. So you see this guy right here? You got the empty hole at 8, the complete dot at 10, and you shade everybody in between. It's every number in between 8 and 10 with the empty hole at 8, with the black dot at 10, and everybody in between. So it's the set of all x such that x is in between 8 and 10, where x could be possibly equal to 10, but not equal to 8. Okay. And we get the idea there too. Now, sometimes you can leave off the lefty and include the righty, or vice versa, right? You can leave off the lefty, include the righty. You can leave off the righty, include the lefty. You can leave off both. You can include both. You can do all sorts of stuff. Here, if we leave off both, so draw neg 8 to 0, and you shade it, and then you draw neg 3 to 10. Now neg 3 to 10, well, neg 3, now guys, question, let me ask you something. Neg 3 he was already in the zone, right? Neg 3 trespassed into neg 8 0 zone, didn't he? Negative 3 trespassed. So we're not going to get a disjointed interval. We're not going to have what's called two broken intervals because negative 3 trespassed. So we're not going to get two broken intervals, but negative 3 has trespassed. Negative 3 has trespassed. So we have negative 3 to 10. Now, let me go and do my 10. But that's very important to see that negative 3 has trespassed. That's not trivial. That's important. So negative 3 has trespassed. And let me go ahead and finish shading. I need neg 3 to positive 10. But guys, since negative 3 trespassed, all this is included. And you don't keep these white dots in the middle because this region everything was included in the middle here. The only thing that truly gets a white dot exclusive is neg 8 and positive 10. So the final answer is to shade everything between neg 8 and positive 10. So the final answer is the open interval, negative 8, positive 10. Okay. Now, the next one, again, we kind of need to do the same test, but now intersection's different. Intersection is strict and stingy. Now, we may get an empty intersection. Question. Does negative 2 trespass neg 7, 0? Yes, it does. So we don't have an empty intersection. Okay, and I can go ahead and tell you the final answer is going to be the more strict lefty to the more strict right-hander. Negative 2 is the stricter lefty because it leaves you less space to play with. As you can see, like if I go way over here, well, of course it does. Negative 2 is the less lefty of the lefties. It's the more strict lefty. It doesn't leave you as much left-handed space to play with. So neg 2 is the less strict lefty. Is the more strict lefty. It's the stricter, more strict lefty. And indeed, to see that, well, let's graph. Let's do the graph. Let's do neg 7 to 0. It's neg 2 to 0. 0 is the stricter right-hander. Again, 0 leaves you less right-handed space to play with on the opposite end. But let's see what that means. Neg 7 to 0. These are all parentheses, so it's going to be all white dot. Now, neg 7 to 0. Now, we may be empty, but we've already established that we have that we're not. And why are we not empty, guys? Why are we not empty? Because neg 2 trespasses neg 7, 0. So neg 2 trespasses. So trespasser, neg 2. So we're not empty. But that white dot's not going to stick, though. So neg 2, well, actually, yeah, it does stick. It's intersection. Yes, actually, it does stick. For union, it wouldn't stick. Now, neg 2 to 7 is there. Okay. And let me get rid of the neg 2 to 7 real quick. I needed to shade first. Let me shade. I need to shade this. Then I need to do. Now neg 2. Since neg 2 is open, since neg 2 is exclusive, it's going to create an empty hole for real. Because the reason it does is we're doing intersection. So now neg 2 is here. And that was an exclusive empty hole. So now neg 2 to positive 7 is over here. Oh boy. So negative 2 to positive 7. Now neg 7, 0. Now neg 2 is where we started. So we know. So neg 7, 0 is this guy. And then neg 2 to positive 7. Oh, there it is. It's already over here. Okay. Well, I need to shade it. Oh boy. Okay. Now, guys, what I've got to do is I've got to pick the greater lefty and the lesser right-hander. The greater lefty is -2, and the lesser right-hander, the lesser of 0 and 7, is 0. The more positive lefty is -2. The more negative right-hander is 0. So my final answer is going to be -2, 0. And in a way, my drawing was not really as fruitful as I wanted it to be. Notice my two middlemen. Well, let's look at my drawing. But let's not throw off on it. Let's look at it. Who's in the middle? Guys, who's in the middle? -2 and 0, right? There we are. We can see it. In a way, my drawing is wonderful. -2 and 0, right? It's your region in the middle, right? It's your middle region. It's this region right here, -2, 0. It's where -7, 0. Here's -7, 0 overlaps with -2, 7. But anyway, so there's that. So it's this region here. It's this middle region of overlap. Notice you have region 1 here, region 2 here, and then region 3 here. You want region 2, which is right here. -2, which is this guy here, which is this guy here. Okay. Whew. Now, here's another intersection. In a way, I don't regret doing the drawing. Now, this time we're brackets, so we need the black dot. Now, -10 to 4. So here's -10. Now, oh boy, but I got to do the litmus paper test. Does 0 trespass the interval -10 to 4? It's in there. It's between -10 and 4. This lefty 0 is in this other interval, -10 to 4. Good. We can proceed. So -10 to 4. So let's do it. -10 to 4. -10 here, and also a black dot at 4. You got to check. Now, just because we have a bracket at -10 doesn't mean we have a bracket at 4. I got to check each separate end separately. But we get lucky, we do. So -10 and 4. Sometimes you'll have like a black dot here and a white dot here, as you recall. Now, let me go ahead and shade. Now, 0 to 6. 0 is here. 6 is here. And let me go ahead and shade. Let me go ahead and shade. Okay. Now, guys, here's the dig. Where's my middle region? Here's region 1. It's always region 2. It's 0 to 4. Just pick region 2, guys. Region 2 is your guy. Region 2 is the region you're looking for. It's region 2. 0 to 4. But just pick region 2. Because region 1 is this big lefty here. Here's region 2, which is the thing we want. And region 3 is this little bitty teeny tiny between 4 and 6. But we don't want that either. We want 0 to 4. We want region 2. It's as usual for intersection. Now, as long as you pass the original criteria that 0 is in -10 to 4. Now, you could do the reverse criteria. There's another criteria you could do, but you could check that 4 is in 0 to 6, right? Now you could either pick on 4 and see if he's in 0, 6, or you could pick on 0 and see if he's in -10, 4. Now, you can't pick the ultra extremas. -10 won't tell you anything. +6 likewise won't tell you anything as far as empty intersection. You got to check for the anomalies. The bad boy for intersection is emptiness. The bad boy for union is disjointed breakedness. I'll tell you what that means in a minute. Okay, now this isn't a bad boy on number 27. It's just you have an empty hole here and a filled in black dot here. That's not really that bad, though. Now, we need to do the litmus paper. Does 0 fit in between -4 and 3? Yes, it does. And if one of them works, the other guy will work too. So that's good. So we don't have disjointed brokenness. So with that being said, well, let's go to town with this math problem. Now, really, all we need to do, now with union, it's different. You don't do region 2. With union, you don't pick the less, with intersection, what you could have done, with intersection, we did 0, like between -4 and 0, we would have picked 0, and between 3 and 4, we would have picked 3. We were no fun. We would have done 0 to 3. That would have been the intersection. But we're not doing intersection. We're fun. We're being fun. We're being generous. We're doing union. We're picking the more generous left coordinate and likewise the more generous right coordinate as well. So the more negative lefty and the more positive right-hander. So we just go from -4 to -4 is more, between -4 and 0, -4 is more negative. And between 3 and 4, +4 is more positive. So -4 to +4. Now, and as far as bracket or parenthesis goes, you just adopt whatever that guy has. -4 had a bracket, so we put the same old bracket on it that it had. +4 here had the parenthesis on it, so we put the parenthesis that it always had. And because +4 had a parenthesis on him, oops, I messed up my graph here. I need to delete this guy, sorry. Because +4 had so it's this green guy, guys. It's not that guy up there. So because +4 had a parenthesis on him, you put an empty hole. And because -4 had a bracket on him, you put a filled in dot, right? So there's that. It's -4 to +4. Okay. And again, I needed to do my litmus at the very beginning. I needed to make sure that 0 fit inside this guy here. And he did. And indeed, if you want to go the other way, you could check that 3 fits inside 0 to 4, and it does. But if one works, the other will work. And if one fails, the other will also fail. Oh boy, now here's number 28. Now here is what I call the problem child. Now, the way they type infinity, they spell it out in British English. -INFINITY. But anyway. Now, we need to graph this guy. Now, this is the generous union, and we would love to say that the answer was all real numbers, -infinity and infinity. But, oh boy, there may be a problem. And there's going to be a problem. Does 7 fit inside -infinity to -1? No, it doesn't. As generous as the left-hand guy was, it wasn't generous enough. 7 doesn't fit. And you could also check that -1 does not fit inside the right-hand guy 7 infinity either. We're disjointed. We have disjointed brokenness. How do we handle this? You just graph it. You leave it alone. You just graph it. You can't simplify this anymore. With 28 guys, you leave it alone. So -infinity to -1, you just graph it. Here it is. And with 7 to infinity, you just graph it. Here it is. It failed the litmus, so you got to graph it. There's nothing else you can do. Don't be a hero. And we put the white dots because these were parentheses at -1 and parentheses at 7, but that's just the same old rule. And if these would have been, like if you had a bracket at -1, sure, you'd have put a black dot at -1, but that doesn't change the global chemistry. Now, and likewise, a bracket at 7 would have put a black dot at 7, all that. But that, again, that doesn't change the global chemistry. Now, but anyway, guys, the litmus failed. You can't mess with it. And you may ask, well, Jason, what if we'd had intersection? Empty set, no graph at all. If this union would have been an intersection, if this cup would have been a cap, you would have had empty set. Your graph would have been no graph at all. I'm not kidding. So watch out for that. Now, number 29, evaluate each expression. So absolute value, this is just a good old recap. So the absolute value of 60 is 60, absolute value -2 is 2. And remember, absolute value just takes off negatives. Now, guys, 15 is bigger than pi, so you keep 15 stays in front of pi. Now, if it's absolute value of 1 minus pi, it would turn into pi minus 1, right? And again, like if that was like, again, if that was absolute 1 minus pi, it would turn into pi minus 1. Pi would go here, 1 would go here, pi minus 1. But with 15 is big enough, it's bigger than pi, so it just stays as it is. Absolute 15 minus pi is 15 minus pi. Okay. And the general rule is if it's absolute b minus a, here's the rule. Absolute a minus b equals a minus b if a is greater than, where's my greater than symbol? Is greater than or equal to b. And on the other hand, absolute a minus b is equal to b minus a if a is less than or equal to b. Now, if you get equal to, you just get 0, and if a equals b, you just get 0 on both sides, and it doesn't matter anyway for equal to. But now, but anyway, so we get these two. So that's the general rule. Like the absolute value. I hate how Word doesn't scroll down. That's the worst. In a way, Word's better than it used to be. In a way, it's not as good. I don't know. So, like absolute 4 minus 7. Let me not use 7. Let me use a symbol called Euler. E is Euler's number. It's about equal to 2.71828. But 4 would certainly be bigger. That's just equal to 4 minus E. Because E is about 2.718. 2.71828. But now, however, since E is a little bit bigger than 2.7, now if you just use 2 is not good, 2 is smaller or more negative. So now if you put 2 in there, you're going to get E minus 2. And E is about, Euler's number is what we call it. You don't know what that is yet, but it's about 2.7181828. That's it's an irrational number, but that's roughly what it equals, But just take my word for it for the time being. Okay. Now, the distance between these two numbers, guys, that's just the length of this line segment here. And that length is 3. Okay, and now find the distance between these two numbers. You just subtract them, okay? And take the absolute value. It's not enough to subtract them, though. You have to take the absolute value if they're negative. You don't want the negative sign. You subtract them, and if they're negative, if you get a negative result, you take the absolute value to make it positive. So like 7 halves minus a negative 11 fourths. This may surprise you, but that's going to turn into 7 halves plus 11 fourths. And that's like 14 fourths plus 11 fourths, which is positive 25 fourths. And since it's already positive, we're good. Okay. And like neg 3 minus 23, guys, that's neg 26. But we got to do the absolute value. So, I mean, neg 3 minus 23 is negative 20. Sorry, neg 3 minus 23 is neg 26. But we got to do the absolute value and make it pos 26. Because distance is never negative, guys. And the moral of the story of today, distance is never negative. And y'all get the idea. I'll leave 32 to y'all. And like if neg 2.2, that's going to turn into, I'll do this one though. Neg 2.2, and if you minus a negative, that's plus 1.6. If I'm $2.20 in the hole, but I gain 160, I'm still 60 cents in the hole, but I take the absolute value. That's 60 cents. I just want the distance. Okay? Anyway, so there's that. And just to recap on those really tough ones, the litmus paper ones, you make sure neg 3 is in neg 8 comma 0. It is, so you can proceed without having the brokenness. And you're not going to keep these white dots here, guys. Don't keep them. So you can proceed without the brokenness, and the broken lineness. And then you keep more what's more generous between, actually you're generous, you're union. So what's more negative generous between negative 8 and negative 3? Of course, negative 8. And what's more positive generous between 0 and 10? Of course, 10 is more positive. So you go all the way neg 8, all the way 10. Think big with union. Think big. With intersection, you got to think limited and small. And let me, since I'm recapping, let me scroll down. Now, intersection, you got to think little bitty. You got to think limited. What's more confined between, we want the more positive lefty, neg 7 and neg 2. We want to confine, we just want region 2. Just graph them and do region 2. That would be the better idea for intersection. Remember, guys, when we did intersection, in summary, you want to graph them and do region 2. Notice this pretty region 2 is neg 2 to 0. And since everything's parenthesis, you do want to honor these white dots here. Now, we would have different dots if it weren't for the parentheses here, but anyway. Now, you got, again, and let me back up on one more thing. You do want to do the litmus paper test. Neg 2 did fit between neg 7 and 0. If it didn't, we would have the empty set, remember? So just keep that in mind. Again, litmus paper 0 does fit between neg 10 and 4. So litmus paper was passed. And region 2, and you graph all this stuff, region 2, but you got to do litmus to make sure you're not broken up. Now 0 does fit, so you're not going to be broken up. So you can proceed. And generous, what's more negative? Which is further to the left? Neg 4 or 0? Neg 4 on the lefties. And as far as the righties go, who's more right? 3 or 4? 4. So that's it. Okay. Now this one, oh boy, everything's out the window. You failed the litmus, you're going to be broken up. 7 didn't fit this one. And actually, when neg 1 doesn't fit this one either, you're broken up. The best you can do, everything's out the window. You just have to graph it. You can't do, you can't do the same old stuff as before. The best you can do is just graph it. You're broken up. Okay. Anyway, guys, that's all for this lesson. I hope that helped. Have a good day. And well, let me do one more, and then just to recap on the union, and then we'll call it a day. Negative 7, comma. Well, no, I've already said goodbye. Thank y'all and have a good day, and I'll do more maybe on the next video. Bye-bye.